SV Math Teach back again. This time we're going to work on the third video in the series on Pythagorean Theorem, where we are applying the Pythagorean Theorem to solve problems. A reminder only that the Pythagorean Theorem is a squared plus b squared equals c squared, and that a and b are the two smallest sides of a right triangle, and c is the longest side. By the way, we call the short sides legs, and we call the long side the hypotenuse. E-N-U-S-E. It has a special name. So with that in mind, let's look at two examples. I have a calculator to my right because I'm going to probably use that. The first one, and you should notice the first one has no image. That's also a key component of solving these problems, is quite frankly just drawing a picture. If you were in my class, I would tell you draw a picture first. So let's read this and draw a picture. A baseball infield is a square turned to look like a diamond. All right, so square turned to look like a diamond. So I'm envisioning something that looks like this. And each side measuring 90 feet. So 90 feet, 90 feet, 90 feet, and 90 feet. All right. How far is the throw from first to third base? Now, first base is over here, and third base is over here. I know that much. And a throw would be this diagonal distance. I also recognize that in the beginning of the question, it says a baseball infield is a square. If it's a square, then that angle down there at the bottom or at the top or on either of these sides is a 90-degree corner. And all of a sudden, look what I have. I have, in a slightly different color, I have a right triangle. I have a right triangle with two legs given at 90 and 90. And the hypotenuse is the missing side. So I'm going to do the same as the procedures in the past. I'm going to start with the Pythagorean Theorem. I'm going to substitute my A and B and C in. And A is 90, B is 90. They happen to be the same. And C is the thing that I don't know, right? C is my hypotenuse. C, remember, C is always across from the 90-degree angle. So 90 is really just 9 times 9 with 2 zeros, so 8100. And again, 9 times 9, 8100. And C squared. Now 8100 and 8100 is 8100 times 2 is 16200. And a reminder to get rid of squares, I'm going to square root. So square root of 16200 is 127.28 feet. Now, again, worth mentioning that here, because I'm rounding my answer, as you can see, I'm going to use this symbol, which means we're approximately equal to 127.28 feet. So it's about 127 feet or so. And that's good enough. In most cases, that's good enough. That's your approximate answer. Second example. My classroom, or my old classroom, was 30 feet wide with a diagonal measuring 52 feet. Now, classrooms, at least mine, was a rectangle. Now, I know it doesn't say it was a rectangle, but we've all been in enough classrooms we can probably guess that. Mr. Lee's old classroom is 30 feet wide, so I'll put 30 feet here. By the way, it doesn't really matter if you're like, wait a second, that's the height, and the width is down here. Okay. Let's put the 30 feet if it'll move for me. I guess it won't move. My Apple Pencil just locked up. So let's put the 30 feet down here. It doesn't make any difference because it says with a diagonal measuring 52 feet from one corner to its opposite corner. So one corner to its opposite corner is 52 feet. It's a rectangular room, so I have 90-degree corners. What's the perimeter of the room? Okay, so two things here. One, I see that I have a right triangle, so I can use the Pythagorean Theorem. But two, what I'm really looking for is the perimeter of the room. So let's be clear that that's what I'm after, right? The perimeter is the thing that I'm after. So I'm going to use the Pythagorean Theorem. I'm going to rewrite the Pythagorean Theorem. I'm going to substitute in my A value, which I'm going to call 30. My B value is just going to be B because I don't know what B is. And my C value is my hypotenuse. It's across from the 90-degree angle. Now, 30 squared is 3 times 3 with 2 zeros, so 900 plus B squared equals, and I don't know 52 times 52, but my calculator does, 2704. I'm going to subtract because I want to solve for b. So subtract 900 from both sides. I'll kind of keep a running total over here with my calculator. I've got b squared equals 1804. I'm going to square root both sides. The square root of 1804, let's see, square root of 1804 is 42.48. So b is approximately equal to 42.48. And for the sake of the drawing, I'm going to write that on here, 4248 and 4248. And since the bottom side was 30, the top side would be 30 as well. So now I'm just going to add up the four sides I'm going to highlight. 30 and 4248 and 30 and 4248. So 30 and 30 and 4248 and 4248. And I typed all that incorrectly, so my answer is still approximately, because I had to round, but again, not a big deal, 144.96, and this is in feet, so feet. And that's it. So application problems, draw yourself a picture, try to label everything, and then apply the Pythagorean theorem where you need it.